Hi, 8th grade. Back on the Friday before we started spring break, I sent out a survey to you asking for feedback on how class was going. And one of the comments that I heard a number of times was that people were a little bit confused with this information that we talked about in section 1.2 and the information we talked about in section 1.3. So what I've decided to do is to create two separate videos, one to review each section. This is the video reviewing section 2. The next one you'll see reviews the stuff from section 3. You'll get another chance to practice all this content as well in the homework that was assigned for today. If you have questions or comments in addition to what you learned today or after what you learned today, feel free to check out our Google Hangout this afternoon. Let me know, I can help you there too. But section 2 was all about measuring matter. So remember that matter is just stuff. It's the stuff that makes up everything in the universe. Everything from you and me to this wooden table to this glass measuring cup. Everything's made up of matter. And we're going to measure matter in a variety of different ways. If we can't measure matter, it's really hard for us as scientists to do anything with it. So section 2 talked about measuring matter in its mass, in terms of its density, and in terms of its volume. So those are the three ways that we're going to be measuring matter, breaking it down today. The first of those measurements was mass. So the measurement mass just means, or has to do with how much stuff exists inside of a piece of matter. So in the case of this piece of granite, if we want to figure out its mass, what we're really looking for is the amount of stuff that makes up this rock. We measure mass oftentimes using the label grams or a variation thereof. The two most common tools that we'll use to measure mass are the triple beam balance and the electric scale. So remember, with the triple beam balance, you're going to put your object on the metal plate. You're going to need to move these weights. We have a hundreds weight, a tens weight, and a ones weight until the line on our beam matches up with the 0 mark on the line of our post. And if you look here, I've already done this, we end up with a mass of this rock at approximately 39 grams. I'm going to add the 30 grams from my tens weight and the 9 grams from my ones weight. If I wanted to calculate mass on an electric scale, it's way easier. All I have to do is turn it on, make sure that my label at the bottom is set to grams, and put my piece of matter on the scale. And you'll notice that here, if I don't move the table, it comes to approximately 39 grams as well, 38.9 if I'm reading correctly upside down. So that's mass. That's the amount of stuff that makes up an object. The other term, though, that gets a little bit confusing, and they talked about it in section 2, is weight. So here I have a bathroom scale, and if I were to weigh myself on this bathroom scale, I'm no longer figuring out how much stuff makes me up. If I'm calculating weight, if I'm weighing myself, now my measurement has to do with gravity. So while mass is the amount of stuff that would make up an object like you or me, weight is a measurement of how much gravity is pulling down on that object. So while my triple beam balance will tell me that this piece of granite weighs 39 grams no matter where I am in the universe, this scale would not tell me that this piece of granite weighs the same number of pounds everywhere in the universe. This piece of granite would weigh less in pounds on the moon because there's less gravity pulling this piece of granite down toward the moon's center than there is here on Earth. So mass and weight are different because weight has to do with matter. That's what we really want to know about in section 2. Whereas, mass has to do with matter. Whereas weight has to do with how hard gravity is pulling that matter down toward the object with the most mass. So after measuring mass, the book moved on to measuring volume. Volume is the amount of space that an object takes up. There's no secret to you that every solid takes up a definite amount of space. This piece of granite takes up a certain amount of space in my hand. That space isn't going to suddenly get bigger, it's not going to suddenly get smaller. That's one of the hallmarks of a solid. It has a definite volume. So to calculate the amount of volume, the amount of space that an object takes up, we have to use one of two techniques. If it's a regularly shaped object, like this prism here, this rectangular prism, we can measure the volume super simply. We're going to use that formula that we've been learning in math class since probably 3rd or 4th grade. Length times width times height. Volume is equal to length times width times height. So to take the measurement of a regularly shaped object, all I need is a ruler. I'm going to measure in centimeters because that's metric and scientists tend to use metric. My first measurement will be the length of this regularly shaped object, in this case it's a book, and it comes to right around 13 centimeters. That might be backwards. Oh well. Then I'm going to measure the width of my regularly shaped object. If I'm measuring in centimeters, that comes to about 18 and a half. I'm going to do this the right way. These were not skills that they taught in teacher school. The last measurement to find the volume of a regularly shaped object is height. And so if I take my ruler and I measure the height of my book, it looks like it is about 3 centimeters. Now, following my formula, the next step would be to multiply my length measurement, which is 13 centimeters, by my width measurement, which is 18.5 centimeters, by my height measurement, which is 3 centimeters. Now, at the end of this, I'm going to end up with, I can't do that math in my head. I'm going to end up with my length times my width times my height. And then for my labels, I'm going to end up with 3 centimeter labels all combined together. To write this in my answer, I'm going to have to cube my work. So the label for the volume of a regularly shaped solid is going to be cubic centimeters. We have 3 centimeter labels we're multiplying together. Now the game changes a little bit. If I go from a regularly shaped object, like this book or the cube in my picture, to an irregularly shaped object. That's just a fancy way of saying an object that I can no longer measure accurately using a ruler. If I have an irregularly shaped object, I'm going to use a strategy, a technique called water displacement. To do the water displacement technique, you're going to need a measuring beaker or graduated cylinder. I pulled these beakers from the lab. You probably don't have one of these at home. That is okay. Many kitchen tools have milliliter measurements built into them as well. So I pulled a couple of measuring cups from my kitchen. You'll notice that these have milliliter labels on them. I've got a small one and a big one here. You probably will be able to find that on your measuring cups in your kitchen as well. So the first thing that I need to do when I'm using the volume displacement technique is fill my graduated cylinder or my measuring cup to a set volume. Milliliters, here we go, are going to be measured along the side of one of these beakers. When you fill up your container, you want to make sure that you are measuring the water level at what's called the bottom of the meniscus. Remember that the meniscus is the lowest part in the water, or of the water inside of a container. The reason that water is going to take on this U shape is because water has this really unique property called surface tension. And so the water molecules along the sides of our container are actually going to cling to the side. They're going to start to raise up a little bit, climb up that glass wall. And that's not going to be an accurate measurement if we measure up here. So we're looking for the lowest point, and that's where we're going to place our mark. In this case, our lowest point falls at 100 milliliters on this 250 milliliter beaker. Once we know the amount of water inside our container, we can add our irregularly shaped object, and you'll notice that because that object, in this case the piece of granite, has a volume, because it takes up space, it forces some of the water in that beaker up. It forces it out of its original position. So to figure out how much volume this rock has, all we need to do is measure how much the water level increased when we added the rock to the beaker. So we started at 100 milliliters. The second line here would be the 125 milliliter line. I would say it looks like the water level rose by roughly 20 milliliters when we put that piece of granite in. So we can take that measurement and we can go back to our formula page here. We have a rock that is able to displace 20 milliliters of water. Now, milliliters is a great label if we're dealing with a liquid. Not such a great label if we're dealing with a solid. So the last step in calculating the volume of an irregularly shaped object is basically just to change the label. We can do this because 1 milliliter is equal to the exact same amount of space as 1 cubic centimeter. So we could say that our piece of granite has a volume of 20 cubic centimeters. That's the long and short of how we measure the volume of an object. Now the last type of measurement that the book talked about in section 1.2 was density. Density takes everything that we've learned in this video and it puts it all together. So density is the amount of stuff that exists in a set amount of space. This is the reason why a hard rock about the size of my fist and a hollow wiffle ball about the size of my fist feel very different when I hold them in my hands, because that solid rock is very dense. It's got a lot more matter packed into that amount of space than the wiffle ball does. The wiffle ball has a plastic case, but other than that, it's mostly gas, right? It's mostly air, it's open. And so density is going to basically calculate how much stuff exists in a certain amount of space. For that reason, we need, in order to find density, to know about the mass of an object, and we have to know about the volume of an object. Our formula for density is going to be m/v, or mass divided by volume. So with my sample of granite, when we measured it on the electric scale, we learned that that piece of granite has a mass of approximately 39 grams. And when we measured that piece of granite using volume displacement, we found that it had a volume of approximately 20 cubic centimeters. So in order to find the density of my piece of granite, all I need to do is divide my mass by my volume. When I run that calculation through my calculator, I'm going to get my density answer. And notice that my labels here are going to need to combine as well. I have grams on the top. I have cubic centimeters on the bottom. That will be the label attached to my number. So when we're measuring mass, or when we're measuring matter, we're measuring the stuff that makes up all the objects in the universe. We can measure the amount of stuff with mass. We can measure the amount of space that that stuff takes up if we're talking volume, or we can put all of that together and we can measure the amount of stuff that exists in a set amount of space. That would be density.